our next lecture, and this lecture has to deal with the fact that it gets pretty hot in the summertime and pretty cold in the wintertime. Why is that? Why do we have seasons? Now, I'm sure some of you probably already have a good idea about why we have seasons. Some of you may have given in to a very popular misconception about why we have seasons, but we're going to uncover all of that today. So let's jump in. Our goals for today are to know how the distance from the sun changes throughout the year, to understand the tilt of Earth's axis and how it affects when we get more intense sunlight versus when we get less intense sunlight, and then to know how the angle of incoming sunlight affects a location's temperature. And that's kind of a review from the last lecture. All right, so let's begin by talking about Earth's orbit. So, you all know that the Earth orbits the sun. And the Earth actually orbits the sun in a flat plane that we call the plane of the ecliptic. Now, what this means is that even though the Earth is revolving around the sun, it doesn't move up or down relative to its path of orbit. It stays on a flat plane. Now, one thing a lot of people don't know about Earth's orbit is it's in fact elliptical. If you've never heard of what an ellipse is, it's essentially an oval. Yes, Earth's orbit is not a perfect circle. It's actually a slight oval. And we'll talk about that in a few moments. Now, with that said, there's an interesting consequence to this. And the consequence is that there's actually a time of the year when the sun is farther away and a time of the year when the sun is closer. Now, if you're like me, you would probably quickly think, okay, so the sun is going to be closer to the Earth, or the Earth's going to be closer to the sun during our summer season, and it's going to be farther away from our sun during the winter season. But that's actually the opposite of the truth. The fact of the matter is, the Earth is actually closest to the sun in January. And in January, the Earth is approximately 147 million kilometers away from the sun. We call the day that it's closest to the sun perihelion, and that occurs approximately on January 3rd. On the other hand, the Earth's actually farthest from the sun in July. And interestingly enough, it's actually on the 4th of July. We call that day aphelion. So if you want to impress your friends on the 4th of July, run around yelling happy aphelion, and they'll all look at you weird. But it's also true. On the 4th of July, we are the farthest away from the sun, with an average distance of 152 million kilometers. Now, with this said, the difference between 152 million and 147 million isn't extremely substantial. And as a result, we only get slight variations in how much sunlight we receive due to these changes in distance. So, distance from the sun isn't really the key thing that gives us seasons. And if it was, well, the whole world would be in winter in June, July, and August, and the whole world would be in summer during December, January, and February. Well, we're going to talk a little bit more about seasons in a moment and what actually creates them. To understand what actually creates them, we have to understand that Earth's axis is actually tilted. So rather than the Earth rotating on an axis that stands straight up relative to the Earth's motion, the Earth's axis is actually tilted. And it's tilted at approximately a 23.5 degree angle. Now, this angle does change slightly over time, but we're going to save that for another lecture. Because the Earth is tilted, this actually results in a situation where one side of the Earth, we call these hemispheres, gets more sunlight than the other. And the hemisphere that gets more sunlight is usually the spring and summer hemisphere. The hemisphere that gets less sunlight is usually the fall and winter hemisphere. Let's talk about this. So, from March through September, so the beginning of our spring to the end of our summer, the northern hemisphere, that's everything north of the equator, is getting the most sunlight. And as a result, spring is from March through June, and then in June, the sun actually has traveled the furthest to the north. It's directly overhead at 23.5 degrees north. And that marks the beginning of summer. And then summer is from June through September. On the other hand, though, when we actually go from September into October, November, and December, what's actually happening is the northern hemisphere is getting less sunlight than the southern hemisphere. As a result, the northern hemisphere cools down, southern hemisphere warms up. That gives us our fall and winter months. Fall is September through December, and then in December, the sun is the furthest south that it goes. It's directly overhead at 23.5 degrees south, and that marks the beginning of astronomical winter. And then winter is from December through March. In the southern hemisphere, they get more sunlight in the months of September through March. Now, one interesting thing about seasons on our planet is seasons actually flip when you go from the northern hemisphere to the southern hemisphere. They actually flip when they go from the northern hemisphere to the southern hemisphere. As a result, the southern hemisphere's spring is in September through December, and their summer is December through March. That's our fall and winter. But for the southern hemisphere, that's their spring and summer. And then their fall and winter is March through June and June through September, respectively. So again, the seasons essentially flip when you go from the northern hemisphere to the southern hemisphere. This is also another reason why distance from the sun has very little to do with seasonal variation. Because if it had a lot to do with seasonal variation, both hemispheres would experience the same season. It'd be summer here and summer in Australia. It'd be winter here and winter in South Africa. It would be spring here and spring in Argentina. But that's not the case. Again, when we're in summer here, they're in winter. When we're in winter here, they're in summer. When we're in spring here, they're in fall. And when we're in fall here, they're in spring. Now, with all of this said, the reason why we have seasons isn't just because the Earth's axis is tilted, but because that tilt stays pointed in the same direction as the Earth orbits the sun. Currently, the Earth's axis is tilted at a star called the North Star, and it remains that way as the Earth orbits the sun. As a result, as the Earth is orbiting the sun, we have a time of the year when the southern hemisphere gets more sunlight and more direct sunlight, and a time of the year when the northern hemisphere gets more direct sunlight. Now, it's worthwhile to memorizing these dates because these are very important dates on our astronomical and meteorological calendars. So these are dates that are worth remembering. In the northern hemisphere, our summer solstice takes place on either June 21st or 22nd. On that day, the sun is directly overhead at 23.5 degrees north. We actually call that latitude the Tropic of Cancer. So on that day, the sun is directly over the Tropic of Cancer. After that day, the latitude that the sun is directly overhead begins to move back south. So on the day of the summer solstice, that is the farthest north that the sun travels. And it also marks the first day of astronomical summer. After that day, the sun begins moving south. On the other hand, 6 months later, the sun is the furthest south that it goes. In that case, it's directly over 23.5 degrees south, which is called the Tropic of Capricorn. That represents the farthest south that the sun travels, marks our first day of astronomical winter. After that day, the sun begins to move north again. So, interestingly enough, even though our summer months are usually June, July, and August, after June 21st, the sun is beginning its trek back down to the southern hemisphere. And even though our winter months are December, January, and February, after December 21st or 22nd, depending on where you're at on Earth, the sun actually begins creeping back to the north. And you'll actually begin to notice this if you're taking this course during the summertime. Take a look and see how much shorter the days become throughout the duration of this course. On the other hand, if you're taking this course during a winter quarter, watch how quickly the days get longer and longer. Usually about a month after the solstice, you notice it pretty well. You get a pretty good feeling that, okay, the days are getting shorter or the days are getting longer. So here's how the northern hemisphere looks like right around the summer solstice. In this time, the sun's over here, and the most direct sunlight is occurring over the Tropic of Cancer. Now, 6 months later, when the Earth is on the other side of its orbit, it looks like this. In this case, the sun is directly overhead on the Tropic of Capricorn. There are two other important days that I want you guys to know about as well. There are 2 times of the year where the sun is directly over the equator. These 2 days are called equinoxes. On these 2 days, both hemispheres are getting equal amounts of sunlight. And on both of these days, the day is approximately 12 hours long. Now, it might vary a little bit because of the curvature of the Earth or elevation, but both locations, or both hemispheres, you're getting exactly 12 hours of sunlight, 12 hours of the sun not being there. The spring equinox is approximately March 21st, and the autumn equinox is approximately September 22nd. And again, these days might vary slightly based on what time zone you're in, where you're at on Earth. There's a lot of moving parts there. So this image is taken from NASA, and it actually shows you how the amount of sunlight a location gets varies with seasons. During the spring and fall equinoxes, you can notice that both the northern hemisphere, that's everything up here, and the southern hemisphere, everything down here, it's getting the same amount of sunlight. During the summer solstice, you notice that the northern hemisphere is getting a much larger chunk of the pie, much larger chunk of sunlight, whereas the southern hemisphere is getting much less. Then in September, we go back to equal amounts from north to south, and then December, southern hemisphere is getting the bulk of the sunlight. Now, what all of this actually does is this results in changes of solar angle throughout the year. So solar angle changes throughout the year. Now, the reason why this matters is because when the sun is low on the horizon, the amount of sunlight that you get is much less intense. The reason why is because as the sunlight's hitting you, it's spreading over a larger area. Therefore, it's more diluted. On the other hand, in the summer months, when the sun is higher in the sky, you're getting much more direct sunlight, and it's much more concentrated. As a result, the amount of incoming shortwave radiation, remember from the last lecture, that's sunlight, varies throughout the year. This affects a lot of things. It affects the length of the day. During the summertime, we have very long days. Why? Because the sun travels higher in the sky, so it takes longer for it to go back down into the horizon. And also, as I already mentioned, the angle of incoming sunlight. Higher in the summer, more direct sunlight. Lower in the winter, less direct sunlight. And this is just a quick review of that. This is what's called the angle of insolation. Now, insolation is just a fancy term for incoming, solar, ation, radiation. So the word insolation means incoming solar radiation. And the angle of it greatly influences how intense the sunlight is. A few lectures ago, I had you take a flashlight and shine it from directly overhead. And if you did that, you would notice that there was a relatively small circle that was very bright on the surface that you were shining the light on. However, as you lower the flashlight onto the horizon, that circle becomes wider and dimmer because the same amount of sunlight is now being spread over a larger area. Hence, it's more diluted, it's just less intense. Now, with all of this said, where you live on Earth greatly impacts the kind of seasons you have. If you live near the equator in what are called the tropical latitudes, roughly between 0 and 23.5 degrees north or south, you are going to have plenty of sunlight year-round. In fact, there are times of the year where the sun is directly overhead. And even when it's not directly overhead, it's still coming in at a very high angle. As a result, you get consistent amounts of heat year-round, and as a result, it's pretty consistently warm. So if you live near the tropics, there's almost no seasonal variation. It's hot year-round. As a matter of fact, I have friends who live in Nicaragua, and the way they define their seasons isn't so much by how hot or cold it gets, but it's actually by how wet or dry it is. And that's just a fascinating little fact. In the mid-latitudes, that's between 23.5 degrees and 66.5 degrees, you get some pretty noticeable variation from summer to winter. Plenty of sunlight in summer, less sunlight and more indirect sunlight in the wintertime. As a result, summers are pretty warm, winters are pretty cold. And so you can get a pretty noticeable difference. However, the most extreme difference you'll notice here on Earth is actually in the polar latitudes. In the polar latitudes, and those are between 66.5 degrees, which is called the Arctic Circle in the Northern Hemisphere, and the Antarctic Circle in the Southern Hemisphere, and 90 degrees, which is the North Pole or the South Pole. In the polar latitudes, during the summertime, you have substantial amounts of sunlight. And in fact, depending on where you're at, you may even have days where the sun never sets. However, in the wintertime, you get little, if any, sunlight. So you get a very large temperature variation from winter to summer. And in fact, in the next lecture, I'm actually going to show you an instance where there's one location on Earth where the difference between wintertime and summertime is over 100 degrees in temperature. That is insane when you think about it. But again, just to remember this, tropical latitudes, warm year-round. Mid-latitudes, warm in the summer, cool in the winter. Polar latitudes, warm in the summer, mild-ish in the summer, very cold in the wintertime. Now, with all that said, the last thing I'll mention is we celebrate a lot of holidays during the beginning of the winter season. And we celebrate Christmas, Hanukkah, Kwanzaa, New Year's, and so on. And those holidays are oftentimes celebrated all around the world. Well, interestingly enough, if you live in Australia, places where it's summertime in December, Christmas isn't so much a hot chocolate, bundling up, and sitting under a tree kind of holiday. It's a barbecue, go to the beach kind of holiday, kind of like what our 4th of July is for us. So, happy holidays from Australia on a nice, hot, summery day. I'll see you all next time.